Hello, welcome back. In this video, we are going to learn about OSI Model Part II. So let's look at the agenda. We would be starting with transport layer, then network layer. After that, we would be learning about data link layer. We would be ending the video with understanding of the physical layer. So we are going to learn about the transport layer. Let's see what are the functionalities of transport layer. Transport layer basically provides reliable message delivery from process to process. What is the meaning of process to process? A process is program in execution. So we have various processes running at the transport layer. So from the sending station process to the receiving station process, it provides reliable message delivery. It also looks into the problem of data duplication and takes proper measure so that there is no data duplication during the process of message delivery from process to process. It also checks that messages are transferred from the sender to the receiver intact. That means there is no modification of data during passage of data delivery through the transmission medium. It can use two different types of protocol. One is called the Transmission Control Protocol, also called TCP. This is basically a connection-oriented protocol. And it can also use UDP. This is also a protocol that is used at the transport layer for proper message delivery from process to process, and this is called User Datagram Protocol. This is a connectionless protocol, and this is basically unreliable in the sense that no acknowledgement is received from the receiver upon sending any packet. On the other hand, this TCP is connection oriented as well as it is reliable, because for each transmission an acknowledgement is received. So let us understand what are the functionalities in short. So as it is giving us reliable transmission of data from process to process, so it is used for service point addressing, also called SAP. So the service point addressing means for each process, let's say we have a transport layer here, and let's say there is a process P1, process P2, and process Pn happening. For each processes, we will have an address. And that address is known as service point address. Whenever a data is transferred from the transport layer of the sending station to the transport layer of the receiving station, this address of the process is what is aimed at. Next, it can also use for data segmentation and data reassembly. This is because when data is received by the transport layer from the upper layer, that is from the session layer, it receives the data. It segregates the data into various segments. And these segments are called data segments. So each data segment is assigned a unique sequence number. Okay. Now, the sequence numbered data segments are passed through the transmission media, and when it reaches the receiving transport layer, then with the help of this sequence number, proper reassembly of the data is done at the receiving end. Next, it is also used for connection control by using either TCP or UDP protocols. It is also used for flow control. So functionality of flow control is done here, and flow control is not node to node, but it is end to end or process to process. Also similarly, we can have error control, but here also it is process to process error control. Let us understand the flow diagram of the transport layer. Transport layer is the fourth layer of the OSI model. So it will be receiving data from the session layer, which is D5. So it is receiving from session layer. Suppose this is the sending station. So data is being received from the session layer. So it is D5. It moves to the transport layer and it places the various process addresses and forms the D4 data segment from the transport layer. Now it moves on to the transmission medium, passes through the transmission medium, goes to the destination computer. If we write that this is the destination computer, here this D4 data is received. It goes to the transport layer, performs all the functionalities, and then it can send the D5 data to the session layer of the receiving computer. So this is the flow diagram of transport layer. Let us understand now what network layer is all about and its functionality. Network layer is basically responsible for moving packets from source to destination with the help of IP addressing. This is the third layer of the OSI model from below. Device IP addressing is mainly done based on whether we are using IP version 4 or IP version 6. Best part based on the network conditions is also done here. So basically it also takes care of the routing techniques for passing the data through the nodes of the network. As I said, it is either based on IP version 4 or IP version 6. If we use IP version 4, the addressing bit will be 32. And if we use IP version 6, addressing bit will be 128. So in short, it can be used for internetworking, it can be used for addressing, it can be used for routing, and for packetizing. This packetizing means the data that it receives from the upper layer, which is the data segment from the transport layer, is converted to internet packets. And this conversion of data segment to IP is known as packetizing. Next, we look into the flow diagram of the network layer. The network layer is a third layer, so it will be receiving D4 data from transport layer. On receiving the D4 data, it will convert it to IP, and what we get is the D3 data. The D3 data then passes through the transmission medium. Now this is the sending computer and we have a receiving computer over here. Here passes through the channel, it goes as D3 data to the network layer of the receiving computer, and basically what we get is the IP. From there it can transmit it for D4 layer to transport layer of the receiving computer. So this is the data flow of the network layer. Next we go and learn about the data link layer. Data link layer is used for error-free transfer of data frames, and it is the second layer of the OSI model. Here, error-free transfer of data frames happens from one node to another. It is also responsible for unique identification of each device by a proper MAC address. This is the hardware address, which is also called the NIC or Network Interface Card, that resides inside the computer, and it is given by the manufacturer. It is also useful for converting the bits to frames if you think of the receiving computer. So in short, data link layer is used for physical addressing, also used for flow control, but in this case flow control happens from one node to the other node and not end to end. Then error control also happens from one node to the other node, and here it uses various checksum, or it can use cyclic redundancy check. So these are the error control mechanisms that are used at the data link layer. It is also the function of the data link layer for access control. So data link layer basically has two sub-layers. One is called the logical link control layer, and the other one is called the medium access control layer. This logical link control layer is closer to the network layer. It is closer to the network layer, and it converts the IP from the network layer to frames, giving proper header and trailer to the frames. Now these frames then come to the media access control or MAC layer. This MAC layer is closer to the physical layer of the OSI model, which is the lowest layer. And so it transmits the frames that are formed at the logical link control layer to the physical layer. Let us understand the flow diagram. Now, data link layer is a second layer, so it will be receiving D3 data from the network layer of the sending computer. It goes to the data link layer. So D3 data is basically the packets. So when it goes to the data link layer, it forms the D2 data, which is the frames. And these frames then pass through the transmission medium. And when it goes to the receiving computer, these frames as D2 data comes here. It is received at the data link layer, and then it can move to D32 for converting it to D3 to network layer. So this is the flow diagram of the data link layer. Next we go to the physical layer. Physical layer is the lowest layer of the OSI model. We can also call it the layer 1 of the OSI model, and it is closer to the physical medium or transmission medium through which data moves. Basically, it provides a physical media through which the bits are transmitted. So it defines the mechanical, electrical, and procedural network interface specifications. It gives the form, intensity, and frequency of converting the bits to signal. It converts the bits to signal, which is the electromagnetic signal, to be passed through the transmission medium and to be passed through the transmission medium so that it is compatible to it for easy transmission. So basically, the functionalities are line configuration, data transmission. It defines the various topologies of LANs as well as signaling. So let us understand the flow diagram of the physical medium. Now, physical medium is layer 1. So it will be receiving data from its upper layer. That is a data link layer. So it will be receiving D2 data from data link layer if it is the sender. So it comes to the physical layer. It forms the D1 data. This D1 data then gets transmitted through the transmission medium, and at the receiving computer, this data is received. These are basically raw bit streams which are converted to signal, and then signal then passes through the receiving station. It gets the D1 data. So the physical layer helps in getting the data in the proper format at the receiving station. Then it goes to the data link layer to form the D2 data. So this is the basic flow diagram of data link layer. So here I come to the end of this lesson. In this lesson, we have learnt about various layers of the OSI model. We have learnt about the physical layer. We have learnt about the data link layer, network layer, and transport layer of the OSI model. Thank you.